Hello, welcome back. We're ready for Section 3 of Chapter 4. Section 3 of Chapter 4 is a pretty fun one, I think. You get to do a lot of drawing. I would recommend using multiple colors when you're going through and taking these notes. It will really help you understand what we're doing. Okay, we're going to talk about symmetry. We're going to talk about reflecting graphs over things like the x-axis, the y-axis, the origin, and a few others. So in this first reflection, we're going to reflect a graph in the x-axis. Now remember, the x-axis runs horizontally. So we're actually going to reflect it up and down over the x-axis. Watch what I mean here. I want you to graph a parabola that starts at 2, 0, and it intersects at the point 1, 1, and then it intersects at the point 0, 4. And then use some symmetry to get the second half of the parabola. And there we go. Let's call this original graph. Let's call it f of x. This is y equals f of x. That's our original function. Now what I want you to do is reflect the graph over the x-axis. So it still has the same vertex, only now it's going to face down. So instead of 1, 1, it's going to be 1, negative 1. Instead of 3, 1, it's going to be 3, negative 1. 0, negative 4. And 4, negative 4. Now what have we done here? Have we switched x values or have we switched y values? Well, we've reflected up and down, so we've actually switched y values. So instead of f of x, this is the opposite of f of x. Remember, that just means the y values have been switched. So to reflect in the x-axis, you go from y equal f of x to y equals the negative f of x. This reflects a graph up and down over the x-axis. So for instance, if you have a graph that has a vertex of 2, 2, and it intersects the point 1, 1, 3, 1, 0, negative 2, and 4, negative 2. That's our original function. So our original function is actually going to face down here. Well, what I want you to do is switch all the y values. Switch all the y values and graph y equal negative f of x. So instead of 2, 2, we're going to start at 2, negative 2. The y has been switched. Make that note. 2, negative 2. Make that note. Instead of 1, 1, it's 1, negative 1. Instead of 3, 1, it's 3, negative 1. Instead of 0, negative 2, it's 0, positive 2. And 4, positive 2. All the y values get switched. All the y values get switched. That's y equal negative f of x. So let's make that note here. Opposite, this is important, put a star next to this. I can't spell opposite. Opposite y values when you reflect in the x-axis. Opposite y values. So here's a fun little graph. 2, 2, 4, 0. 6, negative 2, 8, 0. It looks kind of like what we're going to talk about second semester, a sine curve. If that's your original function, y equal f of x, then in pink, I'm going to do y equal negative f of x. So instead of starting up, I start down. Instead of finishing down, I finish up. And whoop, boom. And the pink one is negative f of x. All the y values have been switched. That's how you reflect in the x-axis. Now we're going to reflect in the y-axis. Okay, so y equal f of x is now going to y equal negative. Nope, that's wrong. That was what the last one was. It's going to f of negative x. This time the negative's on the inside. And when the negative's on the inside, you flip it horizontally. You flip it about the y-axis. So here's your original function. It crosses at 2, 0, 1, 3, and 3, 3. Just like that. It's a parabola. Boom. Alright, so this was 2, 0, 3, 3, and the other one was 1, 3. Okay? And this is y equal f of x. That's our original function. Now, in green, I'm going to graph its reflection. So instead of 2, 0, I'm going to start at negative 2, 0. Negative 2, 0. Notice the x value's been switched. Negative 2, 0. Instead of 1, 3, it's negative 1, 3. And instead of 4, 3, it's negative 4, 3. It's not perfectly symmetrical, the parabola itself, but it is symmetrical over the y-axis. This is y equals f of negative x. All the x values have been switched. Let's make that note. So to reflect in the y-axis, you switch x values. Switch x values. Here's a real cute little quick example. Boom, boom. If you have that's actually an exponential curve going up, that's y equal f of x. Then instead, it's still going to cross at 0, 1 because the opposite of 0 is 0. But instead of going up to finish, it's going to finish down. It reflects. And this is y equal f of negative x. All the x values have been switched, and the y values have stayed the same. Here's the third type of reflection, absolute value reflections. Absolute value reflections. So here's where we take a generic function, f of x, and we switch it to y equal the absolute value of x. The absolute value of x. Now note here, guys, absolute value is always positive. Absolute value of f of x. Now remember, f of x is just some y. It's just f of x. And the absolute value of negative f of x is just some f of x. It always goes positive. So let's make that note. Negative y values become what kind of y values? They become positive y values. Everything becomes not positive. So make a note here. Negative y values reflect over the x-axis because they go from negative to positive. You see, they go from down to up. The graph stays on or above the x-axis, always. On or above the x-axis. Alright, so here we go. Here's your original graph. I'm going to do it in green. Negative, let's go negative 2, 0. Okay? Let's go 0, negative 2. And 2, 0. That's your original graph. It's a parabola, isn't it cute? Alright, that's y equal f of x. Now over here, I want you to graph y equal the absolute value of x. Okay? So, wherever there was a negative y value, it's now positive. So instead of 0, negative 2, guess what? It's 0, positive 2. It comes up. So this little section of the parabola that's below the x-axis, it's now going to be above the x-axis. Above the x-axis. Watch this. And everything that was already above the x-axis, this part right here, none of it changes because those y values are already what? They're already positive. So you just leave them where they're at. You just leave them where they're at. Zoom, zoom. Zoom, zoom. So it kind of looks like a funky W now, instead of a regular parabola. Whatever was above the x-axis stayed normal. Whatever was below it became positive. That's how the absolute value graphs work. We'll work more with those later in the video. Alright, now we're going to reflect something in the line y equals x. This ought to be fun. So to reflect in the line y equals x, I suppose you need to know what the line y equals x looks like. It's when 1 equals 1, and 2 equals 2, and 3 equals 3. It's when y equals x, right? It's a very common line. It's one of your parent functions that you need to memorize. All right, that's the line y equals x. To reflect in that line, you don't just switch x's, you don't just switch y's, you switch x and y. You switch your x and y values, and I can't spell the word and apparently. You switch your x and your y values. Alright, so here we go. Let's graph a parabola to start off. Let's graph a parabola at 0, 0, and then 2, negative 2, and then 4, 0. And that's good enough for now. Doom, doom, choo, choo. Now, it helps to label your ordered pairs. So this was 2, negative 2. This was 4, 0. And this was 0, 0. This is our original function, y equal f of x. Alright, it's actually the parabola y equals x squared minus 4x. Okay, so in order to graph its reflection, this is what we do. Remember, we switch x and y. So instead of, and this is going to be crazy, instead of y equals f of x, it's actually x equals f of y. Y is the input and x is the output. Write down those ordered pairs that we had from f of x. They were 0, 0, 2, negative 2, and 4, 0. I want you to switch them to now x equal f of y. So all you do to reflect in the line y equals x is you switch your x's and y's. So 0, 0 is still 0, 0. But 2, negative 2 is negative 2, 2. And 4, 0 is now 0, 4. So now plot those points. 0, 0. Negative 2, 2 is up here. And 0, 4 is up here. So look what's happened to this parabola. It's actually kind of been flipped on its side. And that's what happens when you reflect things in the line y equals x. And instead of y equal x squared minus 4x, this is x equals y squared minus 4y. All the x's and the y's have switched. The domain and the range have switched. So what I want to do is just kind of review what it means to graph each of these different types of symmetries. So when you're reflecting in the x-axis, this will be really helpful for you guys. Take all your ordered pairs and you switch your y values. You reflect it vertically. So for instance, if this is your original graph, it looks something like this. If this is f of x, say the point 4, 3 is on there. Plot that point 4, 3. Then this is negative f of x. And your x value stays the same, but your y value switches. That's how you reflect in the x-axis. You reflect up and down. If you're going to reflect a graph in the y-axis, then all your original ordered pairs, now you reflect it horizontally, so your x values switch. They become negative, and your y values stay the same. So if your original graph is this, say you have the point 2, 3, and this is your original graph f of x, then your new graph, boom, will reflect this way. The y's have stayed the same, but the x value has switched. So this is actually the point negative 2, 3. It'll be on the graph, and this is f of negative x. F of negative x. You need to have memorized what the transformations do. Okay, let's go over the other two transformations that we talked about. If you're reflecting in the line y equals x, then all your ordered pairs, x, y, do what? What do? They don't become negative, they don't become positive. That becomes y, x. They switch. The domain and the range switch. That's the best way to think about it. So this is going to be kind of a fun graph. I want you to sketch in y equals x, just like that. Okay? And let's do our original graph is, let's have a little fun with this. 3, 1, and 1, 2, 3, 6, 3, something like that. And we'll do like kind of a curvy graph. We'll say that's f of x. And we can even put an equals y there if you want. Then your new graph, I should have labeled my ordered pairs. So let's put 3, 1, and 6, 3. In your new graph, you just switch your x's and y's. So instead of 3, 1, you have 1, 3. And instead of 6, 3, you have 3, 6. 1, 5, 6. Boom, right about there. And it's going to kind of do one of these. See, it's been reflected over this line y equals x. So this was 1, 3, and 3, 6. And it's not y equals f of x. The pink one is x equals f of y. X equals f of y. Alright, and then there was one more type of symmetry that we haven't really talked about, and that's symmetry in the origin. And what happens here? Well, all your original ordered pairs, x, y, they don't stay x and y. You don't just flip x, you don't just flip y. You flip both. So, you flip, make it negative x and negative y. Right. This actually reflects over the x-axis, the y-axis, and you take the opposite sides. So check this out. Here's your original graph. 0, 0, 1, 1, and 3, 6. So it kind of does a curve. You see that curve? It's kind of tough to tell, but that's what it does. Okay, so we're going to take 1, 1, and what's it going to become? It's going to become negative 1, negative 1, negative 1, negative 1. We've made x negative and y negative. I meant to do this in blue. All right, and instead of 3, 6, we now have negative 3, negative 6. And so it's going to kind of curve like that. Negative 3, negative 6. And so this graph, while the green one was y equals f of x, the blue one, guys, is y equals negative f of negative x. So they both flip. They both flip. All right, very cool. Very cool. Okay, so on a single set of axes, guys, we're going to graph y equals x squared minus 4, y equals 4 minus x squared, and y equals the absolute value of 4 minus x squared. This is going to be kind of a fun one. So here we go. Let's get our graph ready. And let's just graph y equals x squared minus 4. We'll do that one in blue. Y equals x squared minus 4. Well, that's just a parabola that has a y-intercept of 4 and has zeros at negative 2 and 2. Negative 2 and 2. And whoop, and whoop. That's y equals x squared minus 4. Alright, now let's graph the second one. I'm going to do him in green. It's 4 minus x squared. Well, all he's done is flipped over the x-axis. He's flipped over the x-axis. So instead of, in blue, instead of x, y's, if he's flipped over the x-axis, the y values have changed. So it's x negative y's. Alright, check it out. 1, 2, 3, 4. So instead of 0, negative 4, it's 0, positive 4. Instead of negative 2, 0, well, you know what? It's still negative 2, 0. Instead of 2, 0, it's still 2, 0. And whoop, he's flipped, isn't he? But ding, 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 that's y equals 4 minus x squared. 4 minus x squared. That's the same thing as negative f of x, if you want to think about it like that. All right, and then finally, in pink, let's graph the last one, the absolute value. The absolute value. All right, well, that means you take whatever was positive, and you leave it positive, but whatever was negative underneath there, don't go below the x-axis. You're not allowed. You have to reflect it back above along the green curve. So, don't go below. Now you just trace the blue curve. Boom. The pink is y equals the absolute value of 4 minus x squared. Whatever was negative becomes positive. Whatever was positive stays positive. And our last example. Here we go, folks. You're going to have to pause the video now and copy this picture up here. Okay? Try to label those points exactly. I'll label a couple of them for you. This one's 1, negative 1. This one's 2, 0. This one's 3, positive 1. This one is negative 2, positive 1. And this one here is negative 1, positive 1. And then obviously it goes through the origin 0, 0. And you are going to sketch all 4 of these graphs. You're going to sketch all 4 of them, all right? This one I will do in blue. So I'll just put a blue dot there and do it in blue. That's y equals negative f of x. Now what does he do? Negative f of x reflects over the x-axis, so the y's become negative. Here we go. Let's do it. So instead of negative 2, positive 1, I'm going to have negative 2, negative 1 is how he starts. Instead of negative 1, positive 1, it's negative 1, negative 1. All the y values switch. Instead of 0, 0, well, it's still 0, 0. Instead of 1, negative 1, switch that negative 1 to positive 1. Switch the y values. Instead of 2, 0, well, guess what? It's still 2, 0 because you can't do the opposite of 0. But instead of 3, positive 1, you're going to do 3, negative 1. 3, negative 1. Chung, 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 chung. There you go, folks. That's y equal negative f of x. Alright, cool. Well, let's do the second one in green. Now this is where we switch the x values and leave the y's alone. This one's going to reflect over the y-axis. So let me get my graph ready. Chung, chung. Alright, so here we go. This one's a little bit trickier. So instead of negative 2, positive 1, switch x. It's going to be positive 2, positive 1. Instead of negative 1, positive 1, it's going to be positive 1, negative 1. Instead of 0, 0, it's still 0, 0. Up here, instead of 1, negative 1, it's negative 1, negative 1. Switch the x values. Instead of 2, 0, it's negative 2, 0. And finally, instead of 3, 1, it's negative 3, 1. That's how you reflect the graph over the y-axis. Boom. So he is y equals f of negative x. Cool. Alright, let's switch. What color you want next? How about a nice yellow color? And we'll do this one here in yellow. So the absolute value of x is where you take all the y values and make them positive if they aren't already. So I'll do him up here. It's going to be a little tiny, but that's okay. Alright, 0, 0, start there. It's still 0, 0. Negative 1, 1 is already above the x-axis, so leave it alone. Negative 2, 1 is above the x-axis, so leave it alone. So the graph starts out the same. See? Starts out the same. But instead of going down to 1, negative 1, it's going to go up to 1, positive 1. Alright? And then 2, 0, the absolute value of 0 is still 0, so there we go. So see that? Instead of a triangle down, it's a triangle up because it had to go from a negative triangle to a positive triangle. And this last little leg, he's already on the positive side. So you just copy that leg to 3, 1. There you go. And that is y equal the absolute value of f of x. And we got one left. Let's see. Let me see if I can find a fun color. I will do it in, how about white? White will show up pretty well on this screen. Alright, and this is where you switch your x's and y's. You switch your x's and y's. We're going to reflect over the line y equals x. So this is going to be a fun graph. Alright, check it out. Instead of 0, 0, we still have 0, 0. That doesn't change. But instead of, now this is going to be crazy, instead of negative 1, 1, switch it. Now you have 1, negative 1. Alright, let's try that. Now you have 1, negative 1. Alright, let me make that note. That's 1, negative 1. Switch your x's and y's. Instead of negative 2, 1, it's now 1, negative 2. 1, negative 2. So, that's actually what it looks like. Alright, instead of 1, negative 1, you have negative 1, 1. Instead of 2, 0, you have 0, 2. 0, 2. Let me make that note right there. Look, it helps to label a few ordered pairs as you go. And finally, instead of 3, 1, you have 1, 3. 1, 3. That's x equals f of y. Notice it's kind of been flipped up on its side, and that's what happens when you reflect over the line y equals x. That's the line y equals x, and that's how it's been reflected. Alright, that is all for part 1. Study hard, it's a tough section, but I think it's a lot of fun. I will talk to you all later. I'm out.